Good afternoon, everyone. My name is Inusarabi Isa Bodimas. Welcome to Electronics Jamb tutorial. In this video, we are going to solve Jamb 2020 Physics. Here we go. Question 1. Which of the following is a drive unit? A. Kilogram, B. Meter, C. Kelvin, D. Newton. To answer this question, we need to know what is drive unit first. So drive unit is a unit of drive quantity. So what is drive quantity? Drive quantity is any quantity which is depend on other quantities. For example, once a quantity cannot depend on itself, it cannot be obtained by a simple experiment directly. So the quantity is what we call drive quantity. So let us look at the option and choose which one is appropriate answer. A, they say kilogram. So kilogram is a unit of mass, and mass is a fundamental quantity because it depends on itself. It can be obtained from what? Chemical or spring balance. Therefore, mass is a fundamental quantity, and kilogram is a unit of mass, which is a fundamental unit. Therefore, A cannot be the answer. B, meter. Meter is a unit of length, and length is a fundamental quantity because it can be measured directly from a device or from experiment. For example, meter rule, micrometer, swing gauge, vernier calipers, and so forth. So meter is a fundamental unit. And the next option is Kelvin. And we know Kelvin is a unit of temperature, and temperature is a fundamental quantity because it can be measured from experiment or from a device which is known as thermometer. Therefore, Kelvin is a fundamental unit. The last option is Newton, and we know Newton is a unit of force, and we know force is a drive quantity because it cannot be measured directly from experiment or from a device. Force is defined as mass times the acceleration, meaning if we know the mass and we know the acceleration, we can evaluate and find the Newton. Therefore, Newton depends on mass and acceleration. Hence, Newton is a drive quantity. Therefore, the unit of Newton will be drive unit. Therefore, out of the following four options, only Newton is a drive unit. Therefore, the correct option is D. Question 1, D. Now going to question 2. Question 2 said two objects, when having 3 times the mass of the other, are dropped at the same time from a tall building. When they are above the ground, the two objects will have the same A, momentum, B, kinetic energy, C, potential energy, D, acceleration. So now we need to study the system in order to find out which quantity will be the same or which is irresponsible with the mass. That is the quantity which is not dependent on mass. So now let's take momentum and explain and see which one will be the appropriate answer. Momentum is defined as the mass times velocity. That's the mass times velocity. Therefore, from the formula of momentum, we know that momentum depends on mass. Therefore, the higher the mass, the higher the momentum. Hence, in this question, the one with high mass will have the high momentum. Therefore, momentum cannot be the answer. B, kinetic energy, is defined as O is equal to a half mv square. Therefore, in this case, also mass is described in the formula. Hence, the kinetic energy also depends on mass. Therefore, B cannot be the answer. C, potential energy, which is mgh, is mgh. Therefore, also mass here is affected the potential energy. Therefore, C cannot be the answer. The last option is acceleration, which is defined as change in velocity over time. Therefore, in the expression of acceleration, as we can see, there is no mass, which means that acceleration does not depend on mass. Therefore, the object will high mass will have the same acceleration with the object with small mass. Hence, D is the answer. Acceleration is irresponsible with mass is constant. So D would be the answer. Hope you get it. Then question 3. Which of the following is in neutral equilibrium? A. Heavy weight suspended on a string. B. A coin resting on its slant edge. C. A heavy base stable lamp. Then B. D. The beam balance in use. So the correct option here is B. The coin resting on its slant edge, because when you rest a coin on its slant edge, it will tend to come to zero in its new position, or it will remain in equilibrium. Therefore, B is the answer here. So the correct option is B. Question 4. A ball is thrown vertically into the air with an initial velocity u. What is the greatest height reached? So this is a very simple question, as we solved it in the last question paper. So now let us apply equation of motion first. So from this equation, from the equation of motion, which says v square is equal to u square plus 2as. So now let us have a simple diagram here to describe the information. So since it is a projectile motion and we don't have the angle there, so that means it will be something like this. It will go off vertically because we don't have angle. So therefore at this point it will tend to come down, it will tend to come to rest. So this is the greatest, that the maximum height it reaches. So therefore from here to here is the what we call the maximum height. So at this point it starts with initial velocity, and at this point the final velocity will be 0 because it will tend to come down there. So now at maximum height, we know the final velocity is 0 and the acceleration due to gravity is negative now. Is negative because acceleration is always acting, gravity is always acting down, and the motion is up, therefore it's negative now. Therefore we can substitute. This means that 0 square is equal to u square plus 2 into minus g then h maximum. So by making subject as a formula, we find that u square is equal to 2 gh max. So to get h, we divide through by the coefficient of h. Therefore h max is equal to u square all over 2g. Hence the correct option is D, that is u square over 2g. So the correct option is D. Now question 5. Which of the following assumption is made in simple pendulum experiments? A. Suspending string is inextensible. B. Bob has a finite size. C. Bob has a definite mass. D. Initial angle of oscillation must be large. So from our previous question paper, I have proved that the correct option is the suspension string is inextensible. Therefore the correct option is A. The other cannot be the answers because they violate, they are not the assumption of simple pendulum experiment. Therefore question 5, the answer is A. Then question 6. A hot water is added to 3 times its water at 10 degrees C and the resulting temperature at 20 degrees C. What is the initial temperature of the water? So question 6. So we know that the quantity of heat of hot water is equal to the quantity of heat of cold water. This is from Zero's law of thermodynamics. So now I can substitute the formula, but before that, from the information given, we know that the mass of cold water is 3 times the mass of hot water. So therefore, we can substitute the values of the formula. So now here is mass of hot water times specific capacity into the temperature, that the temperature change in temperature of hot water, which is initial temperature of hot water minus the final temperature or equilibrium temperature is equal to the mass of cold water times specific capacity of water into the final temperature minus the temperature of cold water. Let's call it theta only. So this implies that mass of hot water times specific capacity into theta initial minus the final temperature is equal to mass of cold water is 3 times the mass of hot water, therefore 3 times mass of hot water specific capacity of water into temperature final minus the temperature of cold water. So from there we can say that the mass goes mass, specific capacity goes specific capacity, then remains initial temperature minus the final temperature is equal to 3 into final temperature minus the temperature of cold water. So I can now substitute the values. So now this implies that the temperature, that the initial temperature is one we are looking for, then minus the final temperature, which is 20 as given in the question. So it's 20 is equal to 3 into final temperature, which is also 20 minus the temperature of cold water, which is 10. So let's simplify. Now initial temperature minus 20 is equal to 3 into 20 minus 10 is 10. Now theta I minus 20 is equal to 3 times 10 is 30. Therefore theta I is equal to 30 plus 20. So theta I is equal to 50 degrees. Therefore the correct option is option C. Now question 7. 22,000 joule of heat is required to rise the temperature of 1 kilogram of paraffin from 20 degrees C to 30 degrees C. Calculate the specific capacity of paraffin. So question 7. So let us jot down the data first. We have 22,000 joule, and then we have the mass, which is 1.5 kilogram. We have initial temperature, which is 20 degrees C, and we have the final temperature, which is 30 degrees C. So it asks to find the specific capacity. So specific capacity is what we are looking for. So now we apply the formula. The quantity of heat is mc into theta 2 minus theta 1. So we are looking for specific capacity, which is equal to Q1 over, by making use of the formula, m into theta 2 minus theta 1. So let us substitute the values. Here we have 22,000 all over mass, which is 1.5 into 30 minus 20. So by simplification, this is going to be equal to 1466 joule per kilogram per Kelvin. So the correct option is option A. Now question 8. Calculate the amount of heat required to melt 2 kg of ice at minus 2 degrees C to water at 0 degrees C. Specific heat capacity of ice is 2090 joule per kilogram per Kelvin, and specific latent heat of fusion of ice is equal to 33 kilojoule per kilogram. So this is a latent heat of melting of ice. So now question 8. So let us get down the data first. Mass of ice is 2 kg. Initial temperature, or θ1, we call it θ1, is minus 2 degrees C, and the final temperature is 0 degrees C. Again, specific heat capacity of ice is 290 joule per kilogram per Kelvin, and latent heat, specific latent heat of fusion is 33 kilojoule. Don't convert it to joule times 10 power of 3 joule per kilogram without Kelvin, because it's a specific latent heat. Therefore, we asked to find the total heat required to convert the ice at minus 2 degrees C to water at 0. So the total heat, let's call it H. Now we need to convert, before we convert the ice to water, we need to convert this ice from minus 2 to ice at 0 degree. Therefore, we require a heat, that is mass of ice, specific capacity of ice, into the temperature from where it is to the final temperature we are requiring, that is θ2 minus θ1. Now this ice is now converted into ice at 0 degree. So the remaining is to convert the ice into water still at 0 degree, which is a latent heat, because it's a heat required without changing temperature. So we have ice at 0 and we convert it to water still at 0. So you see, we observe no heat, no change in temperature. That means it's a latent heat. Therefore, it's latent heat. So mass of ice times the latent heat of fusion of ice. So that is always what we are doing once we have a case like this. Therefore, you can now substitute the values and get the unknown. So the mass of ice is 2. So 2 times the specific capacity of ice, that is into change in temperature, which is 0 minus 2. This minus is from the formula and minus 2 is from the value. Then plus the mass again, which is 2 times the latent, specific latent, which is 33 times 10 to the power of 3. So by simplification, we have obtained that the value is equal to 74 6 joule. So in the given option, we don't have the option which is corresponding to this, that is 74 36 joule. So but in the option, the answer, or the option which is almost corresponding to the answer, maybe if there is a typing error, is D without this 6. So I think this 6 is a typing error. Therefore, there is no correct option in this question, but the appropriate option can be option D because it's similar to the answer we got. So in this case we can just say that option D is the correct option. I don't know whether it is from Jamb or from the company that published the first question paper. So that is it. Then question 9. So question 9 said, in which of the following substances arranged in descending order of their thermal conductivity? A. Copper, steel, glass. B. Steel, copper, glass. C. Steel, glass, copper. D. Copper, glass, steel. So before I give the answer to this question, we need to know that the conductivity of material. So the conductivity of material is depend on the types of material. For example, know that a metal has the highest conductivity among the material, and among the metal, group 1 metals have the highest conductivity if you are trending to periodic table. So without a long explanation, we always know that copper has the highest conductivity compared to steel and glass, because in this case we have 3 parameters, that is the copper, we have glass, and we have steel. So we know copper has the highest conductivity, then steel, and then glass. So in the question we ask to find the correct answer, which is in ascending order, sorry, in descending order, that is decreasing. So the way I arrange it is the one that will give us the correct answer. The copper comes first, then steel, and then glass, which is the option E is the correct answer. So question 9, correct option is A. Then number 10, the vacuum in a thermoplex helps to reduce heat transfer by A. Convection and radiation, B. Convection and conduction, C. Conduction and radiation, and D. Radiation only. So the correct option is option B, which is convection and conduction. Because convection is a heat transfer by transferring of the medium, and conduction is a heat transfer through a material by contact. Therefore, when we consider a vacuum flux, we know we have only 2 things. We have heat transfer by convection due to the movement of the particle inside the flux, and the conduction because of the contact between the particle and the flux. Therefore, the correct option is option A, which is convection. Is option B, which is convection and conduction. Radiation cannot take place in vacuum place because radiation is a heat transfer by electromagnetic waves without requiring a material medium in the space. Therefore, the correct option is option B. So question 11, to obtain a magnification of 2.5, how far shall an object be placed from the fall of a thin convergent length of focal length dash. So now we ask to find the focal length. In this question, find the focal length. So question 11. So let us jot down the data first. So we know that magnification is always equal to the distance by the object or the image, all over the distance by the object from the lens, and from the question is given as 2.5. So you can now make B to be the subject of the formula. So B is 2.5 U. So therefore, from the lens equation, 1 over F is 1 over U plus 1 over B. So we know that the focal length from the option is 0.2, so we have 1 over 0.2 is equal to 1 over u plus b, which is 2.5 u. So here we're going to find the LCM, which is equal to 2.5 u. So u divided by 2.5 u divided by u remains 2.5, then 2.5 u divided by 2.5 u remain 1. So therefore we simplify. Now we have 1 over 0.2 is 5, which is equal to 3.5 all over 2.5 u. So now cross multiply. This means that 5 times 2.5 u is equal to 3.5. So we are looking for u, then we divide through by the coefficient of u. Therefore, by dividing through by coefficient of u, we have 3.5 all over 5 times 2.5. So this is equal to 0.2h meter. That is the distance of object from the lens. Hence the correct option is option C. So in the figure below, question 12, in the figure below, what is the angle of reflection of the ray? So that is the diagram. I'm going to display the diagram now. So this is a diagram of the question. So we ask to find the angle of reflection. So first of all, let's call this surface to be M1, that is surface 1. Here is M2, that is surface 2. So this, let us name the figure. Here is A, here is B, here is, for example, here is E, here is C, and here is D. So now, and finally here is G. So this ray and this are parallel. So by applying analytical geometry, we know this angle and this angle are what we call correspondent angle. So this is parallel to this, and this are parallel. Therefore, they make the same angle with parallel line. Therefore, they are correspondent angle. Hence, here is also 30 degree. So now, the angle of reflection. The angle of reflection is angle ECD. Which angle? Angle ECD. This is the angle of reflection. So now here is 90 degree as given in the diagram. Therefore, from here to here is 90 degree because it's right angle. Therefore, to get this angle, we need to subtract this from 90 degree. Hence, angle ECD is equal to 90 degree minus 30 degree. So ECD is equal to 60 degree, which is option B. That is the correct option. Whenever you have such kind of question, you just apply your knowledge of geometry. That's all. Question 13. An object is placed 10 cm in front of a concave mirror of focal length 15 cm. What is the position and nature of the image form? So let us calculate and then find the answer. So question 13, our data is we have u is equal to 10 centimeter, that's the distance of object, and also we have the focal length, which is 15 centimeter. So we need to calculate the distance of the image to determine the nature of the image. So by applying length equation, 1 over f is equal to 1 over u plus 1 over b. We are looking for b, therefore we make b to be the subject of the formula, which is 1 over f minus 1 over u is equal to 1 over b. So let us substitute the values. Here f is 15, so we have 1 over 15 minus 1 over 10, which is equal to 1 over b. So the LCM here is 30. So 30 divided by 15 is 2. Then 30 divided by 10 is 3, which is equal to 1 over b. Now 2 minus 3 is minus 1. So we have minus 1 over 30 is equal to 1 over b. Therefore, we take the reciprocal to get the value of b, which is minus 30 centimeter. Negative means, this negative indicates that it is virtual, because initially is concave mirror. So for concave mirror, once you have negative value, then it means is a virtual. Hence, we're going to conclude. Therefore, the correct option is option A, which says 30 centimeter and virtual. So here is 30 centimeter, where the negative indicating that it is virtual. Therefore, the correct option is option A. Now question 14. Which of the following phenomenon explain the formation of mirage? So number 1, reflection. Number 2, refraction. 3, diffraction. So option A is say 1 and 2, only B 1 and 3, only C 1 and 3, only D 1, 2 and 3. So before we answer this question, we need to know what is mirage. Mirage is an optical phenomenon that creates the illusion of water and result from the refraction of light through non-uniform medium. So from this explanation, we know that, therefore, looking through this explanation, we know that the mirage will only result in reflection and refraction. Hence, the correct option is 1 and 2, that is reflection and refraction. Therefore, A is the correct option, that is 1 and 2 only. So answer is A. Question 15. When white light is dispersed by a spectrometer, the component having the shortest wavelength is A, orange, B, green, C, violet, and D, red. So to know this, we need to know the order of increasing wavelengths of white light or spectrum of white light. So in this question, I would like to share a hint with you, my guys. That is a formula which says B big Q. So what this indicating? This is indicating that this B is violet. Violet is less than indigo in terms of wavelengths, and less than blue, and blue less than green, and less than yellow, just from the order, and less than orange, and less than red. So looking out through this, then we can say that the violet have the shortest wavelengths. Therefore, the correct option is option C, which is the violent. Question 16. Which of the following statements is true of ultraviolet, visible, and infrared? A. They are all electromagnetic waves with the same wavelengths. B. Ultraviolet ray has the shorter wavelengths than infrared and produce fluorescence. Infrared ray have shortest wavelengths than visible light and produce a sensation of heat. D. So the correct option in question 16 is B. Apply the same phenomena I applied in question 15. Therefore, the correct option is option B, that is ultraviolet ray have the shortest wavelengths. The other are wrong because A, they are all electromagnetic waves with the same wavelengths. They are all electromagnetic waves but with different wavelengths, so A is wrong. Again, infrared have the shortest wavelengths than visible light and produce sensation of heat, which is wrong actually. Visible has the shortest wavelengths. Then D, wavelengths increase in the sequence, visible, ultra, which is wrong. Therefore, option B is a correct answer. Question 17. A force of 10 Newton acts at a point Y on a rod XYZ as shown in the diagram. If XYZ is 2 meters, what is the moment of the force about point X? So this is the force 5 Newton and this is the distance from X to Y is 2 meters. So we asked to find the moment about point X. So what is the moment? So recall that moment is always equal to the force times the perpendicular distance. So in this case, this force is parallel, it passes through point X. Therefore, this distance will not be considered because it's a parallel distance, it's not a perpendicular. Therefore, the perpendicular distance is 0 here because the force is passes through X, as we can see. I'm showing it. Therefore, the perpendicular distance is 0. Hence, the moment will be the moment is equal to the force times the perpendicular distance. So here our force is 5 Newton, but the perpendicular distance is 0, which is equal to 0 Newton meter. Therefore, the moment here is 0, and the correct option will be 0, which is A. Question 18. To keep a vehicle moving at constant speed B requires a power P from the engine. The force provided by the engine is A. P over B, B 1 over 2B, C PB, and so forth. So let us have a simple expression for this. So in this case, we have the force and velocity and then the power. That is our parameter. So we have power, we have the force, and we have the velocity. So here I'm looking for the expression that related power, force, and velocity. Therefore, I know that power is equal to force times velocity. So in the question, I am asked to find the resultant force. So the force will going to be equal to the power over velocity. Therefore, option A is the answer, which is the power over velocity. So option A is the answer. Question 19. A stone of mass m kilogram is held h meter above the floor for 50 seconds. The work done in joule over the period is A mh, B mgh, C mgh over 50, D 0. So in this question, we know that here we asked to find the work done in joule over this period of time, meaning what? Power, because they say over the period of over this period. So now we know that the power is equal to what? Work done over time. Because they say over this period, it means work, it means power. So now work done is mgh all over time, which is 50. So the correct option here for the question is C, which is mgh over 50. Question 20. A body of mass 10 kg rests on a rough inclined plane whose angle of tilt is variable. This is gradually increased until the body starts to slide down a plane at 30 degrees C. The coefficient of limiting friction between the body and the plane is. So this is question 20, and I solved similar question to this in the last question I solved. Therefore, I just apply the formula I derived there. That is, the coefficient of friction is equal to tan theta for an inclined plane. Here the theta is 30, which is tan 30, and from the table we know that tan 30 is equal to 0.5 h. Therefore the correct option is option C. Question 21. An inclined plane which makes an angle of 30 degrees with a horizontal has a velocity ratio. Here I also solved a similar question to this in the previous question. Question 21. We know that velocity ratio is equal to 1 over sine theta, and here the theta is 30, which is 1 over sine 30 degree. We know that principal angle sine 30 is 1 over 2, therefore we take the reciprocal, which is 2. Hence the correct option here is A, which is 2. Question 22. What is the length of the liquid column in a barometer tube that would support an atmospheric pressure of 102,000 if the density of the liquid is 2,600 kg per meter cube? So now this is a computational question. So question 22. So let us jot down our data. So we know that pressure is always equal to rho g h, or force over area. So now in this case we are looking for height, therefore we make the height to be the subject of the formula, which is pressure over rho g, where rho is the density, g is the acceleration due to gravity, and v is the pressure. So now from the question we have given that pressure is the same as all over rho, not the density, which is 2,600 times acceleration due to gravity, which is 10. Therefore height is 3.92 meter. So the correct options is C. Question 23. 40 meter cube of liquid P is mixed with 60 meter cube of another liquid Q if the density of P and Q are 1 and 1.6 kg per meter cube respectively. What is the density of the mixture? I think I solved a similar question to this in our previous solutions of 2021, but here I am going to solve it again so as you will get the concept. So 23, I don't have to jot down the data, so I will just find the total mass of the mixture. So let's call it mass of PQ, which is the same as mass of P plus mass of Q. So from the formula, density is mass over volume. I know that mass is always equal to density times volume. So mass of P is equal to the density of P times the volume of P. And from the information given, I know that the density of P is 40 times the volume, which is 1, which is equal to 40 kilogram. And again, mass of Q is equal to the density of Q times the volume of Q, and the density is 1.6 times the volume, which is 60, which is equal to 96 kilogram. So now I can find the total mass of the mixture, which is going to be 40 plus 96, which is equal to 136 kilogram, and the volume of the mixture is equal to volume of P plus volume of Q, which is equal to 40 plus 60, which is equal to 100 meter cube. So now to find the density of the mixture, I can just apply the formula that the density of the mixture is equal to mass of the mixture all over the volume of the mixture, which is equal to the mass is 136 all over the volume, which is 100, which is equal to 1.36 kilogram per meter cube. So the correct option here is option D. Then question 24. The resistance of a platinum wire as the ice and steam point are 0.75 ohm and 1.05 ohm respectively. Determine the temperature at which the resistance of the wire is 0.95. So I think I also solved a similar question like this in the previous past question. Nevertheless, this is interpolation. So question 24. So let's assume here is the resistance line and here is the temperature line. So we know that the steam point and the ice point, steam point is 100 and the ice is 0. So this is in degree C and this is in ohm. So now we have another point which is unknown. We call it maybe T. So here we have the corresponding value of steam, that is the upper point and the lower point, which is the upper point is 1.05 and the lower point is 0.75, and the corresponding unknown resistor of the unknown temperature, non-resistor of the unknown temperature is 0.90. So in this case we can apply the interpolation, that is to take the known value and subtract the upper value from each line. Therefore in this case, let us start with resistance line. So 0.9 is a non-resistor minus the lower point, which is 0.75, all over the upper point, that is 1.05 minus 0.75 is equal to the corresponding value, which is T minus 0 all over 100 minus 0. So therefore this, after simplification, is 0.15 all over 0.3 is equal to T over 100. So therefore in this case we cross multiply. So after cross multiplying I make T to be the formula, I find that T is 0.15 all over 0.3 times 100. So now T is equal to 50 centimeter degree C. Hence the correct option is option B. Question 25. The image in a pinhole camera is A. Erect and formed by refraction through a lens. B. Virtual and formed by dispersion. C. Erect and get shape as the hole become larger. D. Inverted and formed by the light from each point traveling a straight line. So in this case the correct option is option D, because light traveling a straight line. So for pinhole camera, the light emerged from a pinhole camera and fell on the object. Therefore it will reflect back with a ray that take the image of the object. But in the reflection, as we can see during an experiment, the object form or the image form is inverted. Therefore, option D is the only correct option, that is inverted and form the light from each point traveling in a straight line. So light is traveling in a straight line and the image formed by pinhole camera is inverted. Therefore, option D is the answer. (26) When a mirror at which a ray is incident is rotated through an angle, the reflected ray will be rotated through 2 theta, as we already derived or explained in the previous question paper. Therefore, correct option is option C, that is 2 theta. Then 27. A trough 12 cm depth is filled with water of refractive index 4/3. By how much will a coin at the bottom of the trough appear to be displaced when viewed vertically from the above water surface? So now let us solve this question. That is question 27. In this question, we know that from Snell's law, real depth over apparent depth is equal to the reflective index. So let's substitute the value. We know that the reflective index is 4/3 and is equal to the real depth, which is 12 over the apparent depth. So to get the apparent depth, we cross multiply, and after doing this cross multiplying, we find that the AD is equal to 3 times 12 over 4. 4 into 12 is 3. 3 times 3 is 9, which is 9 centimeter. So now, but we are looking for the displaying distance or depth. So the displaying depth, that the depth, display depth is always real depth minus apparent depth, which is equal to 12 minus 9, which is equal to 3 centimeter. Hence, the correct option is option A. Question 28. In a ray diagram for sine convergent length, a ray that is not parallel to the optic axis but passes through the optic center will be. So the correct option, without reading the option as we are seeing in the screen, you can just predict the correct option. So for this question, the correct option is A. That is the image, 28. Yeah, that is the image passes through undeviated. I already explained this concept in the previous question paper. If you are looking for the deep concept, you can refer back to the previous paper. So the correct option is option A, because ray incident on the surface at any angle, therefore it remains undeviated. Hence the correct option is option A. So for 29, answer is A. Question 30. Two turning forks of frequency 256 Hz and 260 Hz are sounded close to each other. What is the frequency of the beat produced? So in this question, we know that the beat frequency, let me call it FB, is always equal to the bigger frequency minus the lower frequency. And from this, you know that the bigger frequency is 260 minus the lower, which is 256, from the option 256. which is equal to 4 Hz. Therefore, the correct option is option B, that is 4 Hz. Question 31. A man hears his echo from a nearby hill 2 seconds after the shouted. If the frequency of his voice is 260 Hz and the wavelength is 1.29 meter, how far away is a hill? Meaning what is the distance is a hill? So now let me jot down my data for better understanding. We know that the time given is 2 seconds, and again we have a frequency of 260 Hz. Again, the wavelength, that is lambda, is 1.29 meter. So we asked to find the distance covered. So before finding the distance, we need to know the velocity since we have time. So we apply the expression that the velocity is the frequency times the wavelength, which is 260 times 1.29. So by evaluating, we find that the velocity is equal to 335.4 meter per second. So now then we apply the second formula, that is velocity is equal to distance over time. But in this case, we have the issue of sound wave. It's echo, so we are now counting the distance it go and come, because to hear the echo, that is the reflection of sound. So when it reaches the surface, then it come back. So you have two distance, the one it is going, then the one it is coming back. So it has the same distance. So let the distance be d, and if that is the case, we have d plus d, which is 2d, that is the total distance all over time. So now I'm looking for the distance. Therefore, I can now make the distance to be the subject of the formula, which is going to be equal to velocity times time over 2. So what is velocity is 335.4 times the distance, which is 2 seconds, all over 2. So 2 go with 2, then distance is equal to 335.4 meter per second. Therefore, the correct option is option B. Question 32. When the bottom tip of a vibrating turning peg is held in contact with a wood box, a louder sound is heard. This phenomenon is known as A, hertz, B, echoing, C, resonance. So the correct option is resonance. This is because resonance is a phenomenon in which an acoustic system amplifies sound. The word amplify sound wave whose frequency match one of its natural frequency of vibration. So going back to the question, they say vibrating turning peg is held in contact with a wooden box. Louder sound is heard. That is, amplifies sound is the same. Therefore, resonance is the correct options. Because echoing is just a reflection of sound after a reflection of sound. Yes. D is a reverberation, that is a result of multiple frequency, multiple objects with different frequency, and hit is just a hit. So therefore, resonance is the correct option, which is C. So 32, answer is C. Then 33. When an ebonite rod is rubbed with a probe, it has A, no charge at all, B, negative charge, C, a positive charge, D, negative charge. So the correct option is B, because ebonite has negative charge and probe has no charge. Therefore, the dominant charge will be negative. or the overall charge, because 4 has no charge. Therefore, the correct option is option B. Then question 34. Which of the following factors has no effect on the EMF of primary cell? A. Temperature. B. Size of the cell. C. Nature of the plates. D. Nature of the electrolyte. The correct option is B, because the size of the cell has no effect on the primary EMF of the cell. But temperature has effect because it has effect with a resistor. The nature of plate also has effect. The nature of electrolyte also. So therefore B is a correct option, which that the size of the cell has no effect on the primary cell EMF of the cell. Therefore correct option is B. Then question 35. A wire of length 15 meter made of a material of resistivity 1.8 exponential 2 ohms per meter per Kelvin has a resistance of 0.2 ohm. Determine the area of the wire. So resistivity is ohm meter. So now question 35. So let's get the data. So we have length which is 15 meter, and we have resistivity which is 1.8 exponential 2 ohm meter, and resistor is 0.27 ohm, and we asked to find the area. So from resistor is rho L over A, making A to be the subject of the formula. From here we have A is rho L over R. So A is equal to rho is 1.8 exponential 2 times L, which is 15, L over resistor, which is 0.27. So we now evaluate. After evaluating, we find that area is equal to 1 exponential 10⁴ meter square. Therefore the correct option is option B. Question 36. The diagram above shows a meter bridge in which 2 of the ends contain resistance R and 2 ohm. A balance point obtained at 60 cm from the left end. Calculate the value of R. So this is a meter bridge. So question 36. So now we need to find the balance point. So from the diagram, the balance point or the distance of balance point of R is 60, and for 2 ohms is 40. That is, we can set 100 minus 60 to get 40 there. So this is a just direct proportion. Now we can say that R is proportional to length, always in meter bridge. So now after this we can say from variation R over R1 over L1 is equal to R2 over L2. Remember, R is proportional to L. Therefore in this case we have R, which is unknown, all over the corresponding distance, which is 60, and is equal to R2, which is 2, all over length, which is 40. So to get R, we now cross multiply and make R to be the subject of the formula. By doing so, we have 60 times 2 all over 40, so which is equal to 3 ohm. So therefore the correct option is option C. Question 37. The primary aim in high tension transmission is to A. Minimize electrical loss due to heat production. B. Increase the rate of energy transfer by using high voltage. C. Increase the current in the wire. The correct option is A, because the aims or the primary aim in high tension transmission is to minimize electrical loss due to heat resistance, heat production. That is heat from what? The equation. Heat is equal to I square R. So we need to minimize the heat loss, because heat is trying to decrease the amount of energy transmitted. So we need to reduce the heat or to minimize it for us to have a better transmission. Therefore, the correct option is A. Question 38. Determine the inductive reactance when a 30 mH inductor with a negligible resistance is connected to a 1.3 exponential 4 Hz oscillator. So now this is AC circuit. This is a simple problem from AC circuit 38. So now let us jot down our data. So the inductor is denoted by a sign like this, which is 30 millihertz, which is the same as 30 exponential minus 3 hertz. Then frequency is also given, which is 1.3 times 10 to the power of 4 hertz. And then we have to find the inductive reactant. So we know the formula of inductive reactant is 2 phi watts FL. So we now substitute 2 phi times the frequency, which is 1.3 exponential 4, times the inductor, which is 30 exponential minus 3. So by simplifying, we find that this inductive reactant is 245 ohm. Therefore, the correct option is A. And the second to the last question, which is a conceptual question, which says, which of the following statement correctly describes cathode ray? Number 1, they consist of tiny particles carrying negative electric charge. 2, they are deflected in magnetic field but not in an electric field. 3, they consist of fast moving neutrons and deflected in an electric field. So of course the correct option is option A. That is wrong, because they are only carrying negative charge, that is electron, as we know from radioactivity. That is, the cathode ray is always carrying negative charge. Therefore the correct option is option A, that is number 1 only, because they are not consisting a neutron. Cathode ray is only carrying negative electron or negative charge, that is electron, no neutron, no proton. So number 3 is wrong. Also number 2, they are deflected in magnetic field but not in an electric field, which is wrong. It deflected in both electric and magnetic field. Therefore the correct option is A. And the last question, natural radioactivity is a random spontaneous disintegration of nuclei of heavy isotopes of certain element with the emission of A. Alpha, beta and X-ray, B. Alpha, beta and gamma ray, C. X, alpha and gamma ray, D. Beta, gamma and X-ray. The correct option is option B, which is alpha, beta and gamma ray. As we all know, the natural radioactive process or radioactivity is a random or is a spontaneous disintegration of alpha, beta and gamma ray. Therefore, the correct option is option B, that is alpha, beta and gamma. That is a natural emission of radioactivity. So here we come to the end of this tutorial video of today of Physics 2020 Jamb past question. So before I close, I want to remind us about our YouTube subscription. It's very important. Please subscribe to our YouTube channel. Once we shot a new video, you will see the video. You see the clock showing you that we emerge a new video. So this will ease your work in searching the video from search console. You will just see it in your subscription. So subscribe to our YouTube channel and like our video. This will also motivate us in doing another or many videos to you, as we are all open-minded of helping people doing tutorial in and out the university. This is the starting point, and we hope you guys Jamb waiters or Jamb students to pass your Jamb with flying color. And once you come to university, we are also together with you, because as you can see, we are offering tutorial to university students. So I hope I will meet you in the university. Thank you very much for watching us. Bear with us. Stay connected to our next subsequent videos. Thank you very much.